Friends, myself Dr. Manju Banerjee, Assistant Professor Physics, Government Bilasa Girls PG College, Bilaspur. Today I deliver a lecture on stimulated Raman scattering that is taken from laser spectroscopic technique of paper second, that is laser and laser applications of MSc 4th SEM. Students, first of all, we see that what is Raman effect or Raman scattering. When an intense beam of light, and that light is monochromatic, usually in the visible region, is passed through a sample, a gas, liquid, or solid, and the intensity of light scattered at right angles to the incident light is observed, most of the scattered light will have the frequency of that incident light, and that scattered light is known as Rayleigh scattering. A small amount of light will have frequencies other than the incident beam. When the sample was irradiated with other beam of another frequency, the scattered line contains another line near the exciting one. But if the same light is passed through another sample, the shift of the scattered frequencies are found to be different. Thus, the shift of the Raman lines are found independent of the incident frequency but depend on the sample. The difference between weak lines and exciting lines are found to be corresponding to the vibrational and rotational frequencies of the molecules under investigation, and this effect is known as Raman effect. Thus, we see that there are Stokes and anti-Stokes lines between in the other two parts of the visible spectrum. Now, for the stimulated Raman scattering, let us see what is stimulated Raman scattering. Stimulated Raman scattering has been observed by Woodberg and Ng Echard et al. Using intense ruby laser light for excitation. They have shown that the emission possesses many of the characteristic properties of the stimulated radiation. At present, SRS, that is meant stimulated Raman scattering, has been observed at many different wavelengths from a variety of substances that include liquids and gases at high pressure. When Raman effect is observed with a Raman cell in a laser cavity or with a laser beam focused through a Raman cell, the Raman spectrum shows several orders of both Stokes and anti-Stokes vibrational Raman lines. It is also found that the various order of Stokes and anti-Stokes lines have equal frequency separations and most not the decreasing frequency separation. This special type of Raman effect is known as SRE, that is stimulated Raman effect. The effect can be observed with an arrangement shown as following figure. In this figure, we see that there is a rotating mirror and there is a laser cavity which is Q-switched laser, that may be ruby laser, and there is a particle reflector also, and the rays passing through the laser cavity, the output rays are focused in a lens, and after focusing within a Raman cell, they fall on a prism, and we get Raman lines on the other film. The spectrum shows ruby radiation at 6940 angstrom and several orders of Stokes radiations for bright spots. It also shows several orders of anti-Stokes radiation in the form of cones. In the figure, we see that there are radiations in the form of cones whose radius increases with order number. These cones are anti-Stokes radiations and can be photographed as concentric circles or rings. When no prism is placed between Raman cell and photographic film, this is shown in the following figure. That is, we observe the photographic plate as a concentric circle. And this is the experimental arrangement for production of stimulated Raman and anti-Stokes lights in an externally focused laser beam. The stimulated Raman lines are much more intense than ordinary Raman lines. The ratio of intensity is of the order of 10 to exponential base 10 to exponential base 20. This can be attributed to a gain effect like that in laser active medium to give Raman radiation which is coherent and which gains in amplitude by stimulated radiation. Now, experimental setup shows that the ruby light and the first Stokes and first anti-Stokes line were all coherent. The coherence of SRS, that means stimulated Raman scattering, can be demonstrated by the use of an interference experiment like that shown in the following figure. Now, light from a ruby laser at about 300 megawatts power passes through a Raman cell to the vertical slit of spectrograph, which has a prism. Prism is placed. Two horizontal slits placed before the vertical slit serve to show whether or not the radiation passing through the slits is coherent. If the radiation is coherent, a vertical interference pattern will be shown. Using ruby radiation as a source to obtain stimulated Raman radiation in nitrobenzene, it is possible to obtain first Stokes line at 7650 angstrom with an intensity over 25% of that ruby radiation at 6943 angstrom. Since ruby radiations can be used as powers up to 100 or more megawatts in Raman experiments, stimulated Raman radiations of a number of megawatt power can be obtained. Thank you, students.